Good day. Today we shall be looking at Cambridge A-level paper, October-November, paper 1, variance 2, October-November 2023, pure math 1. Now the first question is the coefficient of x cubed in the expansion of 3 plus 2ax is 6 times the coefficient of x squared in the expansion of 2 plus ax raised to the power 6. Find the value of a. First, what we need to do is to expand. Let's expand 3 plus ax, 3 plus 2ax raised to the power 6. That's the first thing we need to do. You should expand. Three plus 2ax raised to the power 5. So using binomial expansion, raised to the power 5 using binomial expansion. Remember the formula for the expansion. If you have x plus y raised to the power n, the formula for the expansion is x raised to the power n plus n combination 1, x raised to the power n minus 1, y raised to the power 1 plus n combination 2, x raised to the power n minus 2, y raised to the power 2, until you get to where is required. So in this case, our x is 3, while our y is 2ax. So let's make use of and expand. What we need in this expansion is the coefficient of x cubed. So once we get to the power of x with cube, we stop. So if we expand it, the first term should be 3 raised to the power 5 according to the formula. The second term, according to the formula, 5 combination 1, 3 raised to the power 4, 2ax raised to the power 1. The third term, according to the formula, 5 combination 2 times 3 raised to the power 3, 2ax all raised to the power 2. First, second, third. The fourth term should be 5 combination 3, 3 raised to the power 2, 2ax raised to the power 3. If you notice the fourth term, we have a power of x of 3, the power of 3 on x. So hence the coefficient of the coefficient of x cubed, coefficient of x cubed in the expansion we're talking about is 5 combination 3 times 3 squared, which is 9, 2ax cubed, which is 8, a cubed, x cubed. So the coefficient of x cubed will give us, let's do the math, 5 combination 3. 5 combination 3 will give us 10 times 9 times 8, we have 720. So the coefficient of x cubed, coefficient of x cubed means the one beside x cubed. So in this context, this is what is beside x cubed. That will be the coefficient of x cubed. That will be 720 a cubed. That's the coefficient of x cubed. Now, remember the question said the coefficient of x cubed is 6 times the coefficient of x squared in this expansion, which means in the second equation given in the question, what we need is coefficient of x squared. Using the same formula as above, this one, the first term is 2 raised to the power 6. The second term is this. Don't forget why the top term is this. So, and what we need in the second equation is coefficient of x squared. So as you can see, once you simplify this third term, first, second term, third term, you're going to get x with the power of 2. Now what is 6 combination 2? So in this place we have 6 combination 2. 2 is power 4, 16, a squared, x squared. So from here I can get the coefficient of x squared. So the coefficient of x squared here will be 15 times 16. 15 times 16, that's 240. That's 240 a squared. And the question said, according to the question, the coefficient of x cubed is 6 times the coefficient of x squared. Coefficient of x cubed is 6 times coefficient of x squared. Coefficient of x cubed we will give that's kind of 720 a cubed, 6 times coefficient of x squared. What's coefficient of x squared? 240 a squared. Now from here, when you cancel the a, 1 a is left here. 6 times 240, and 6 times 240, we have 1440. So no more a. And you cancel it from here, a is 1440 divided by 720. So the value of a, according to the instruction, we give 2. That's it. Let's move to the next question. Number 2 question. We are asked to find the exact solution of the equation. We have to find the exact solution of the equation. So the equation is 1 over 6 pi arc tan 4x equal to minus arc cos 1 over 2 is 3. So what I would do is that to find the exact solution means to find the value of x. That's what they're asking. Find the value of x. So to find the value of x, you need to make x the subject to formula. So the equation becomes 1 over 6 pi. I'm going to rearrange. Minus arc cos come to the other side, to the left hand side, become positive arc cos half root 3. So separate the one of x to the other side. Let the one of x stand alone. So arctan that is attached to x will become negative. So from here, 1 over 6 pi arc cos of root 3 over 2. If you check your calculator in radian, it's going to give us pi over 6. It's like you're looking for, I think it's like cos 30. It's just looking for cos 30. That's the meaning. Cos 30 is root 3 over 2. So the inverse is pi over 6. So equal to negative arctan 4x. So pi over 6 plus pi over 6, that gives pi over 3. So equal arctan, negative arctan 4x. We call that, if you have something like this, arc tan theta equal to f. What does it mean? It means theta is tan f. The same thing we have here, minus arc tan 4x equal to pi over 3. First, take the negative to the other side. It means negative pi over 3. So end 4x equal tan of negative pi over 3. And tan of negative pi over 3, check your calc, is going to give us negative root 3. So the value of x is negative root 3 divided by 4. That is the exact solution of the equation. Number 3, the equation of a curve is such that the y dx, the equation of a curve is such that the y dx is that the y dx is half x plus 72 over x to the power 4. The curve passes through the point P. Find the equation of the normal to the curve at P. Okay, we are looking for the equation of normal. Equation of normal to the curve at P. Okay, now equation of normal, the formula is y minus y1 equal to negative gradient of tangent x minus x1. That's the formula for equation of normal. Y minus y1 equal to negative inverse gradient of tangent. If you are very strong with your coordinate geometry, you know the reason why the gradient is negative inverse of tangent. Now, what's our tangent? So, our tangent, the gradient of tangent is also the same thing as the y dx. And the y dx is half x at point P. At point P, x is 2 plus 72, x is 2. I put the equation there. So we have 1 plus 72 over 16. I think it's going to give us 11 over 2. Let me confirm that. 1 plus 72 over 16, 11 over 2. That's the gradient of tangent. If the gradient of tangent is 11 over 2, so hence the equation using the formula y minus y1. What is y1? 8 minus 1 over gradient of tangent will give you minus 2 over 11 bracket x minus x1. x1 is 2. So let's simplify. At the end of the day, we have 11y minus 88 equal to minus 2x plus 4. At the end of the day, we have 11y plus 2x equal to 4 plus 88, 92. That's the equation of the normal at point P. Now find the equation of the curve. What is the meaning of finding the equation of curve? It means you have to find the value of y. How do you get the value of y? If the y dx is given, to find the value of y, you just integrate. Since the y dx is given, we call that the y dx. The y dx is half x plus 72 over x raised to the power 4. This is it, which can be written as 72x raised to the power minus 4. So if given the y dx, to get y, you have to integrate both sides. How do you do that? Cross multiply such that the y is half x plus 72x raised to the power minus 4 dx. Then integrate both sides. That's how to get y. When integrate the y, we have y. When integrate half x, that's half multiplied by x squared over 2. When integrate this, that will be minus 4 plus 1 over minus 4 plus 1. Don't forget your arbitrary constant. So from here, the value of y will give us x squared over 4. 72 divided by minus 4 plus 1 is minus 3. 72 divided by minus 3, you have 24. So this will give us minus 24 x minus 3 plus c. Remember that given a point for the curve, there's a point on the curve 2, 8. X is 2, y is 8. Substitute it. Y is 8, x is 2 square over 4. X is 2, so we have this plus c. At the end of the day, 8 equal to 1 minus 3 plus c. 1 minus 3 is minus 2, so here c is 10. So at the end of the day, the equation of the curve, will give us y equal x squared over 4 minus 24x minus 3 means 24 over x cubed plus c. Your c will be 10. This is the equation of the curve. Number 4, the diagram shows the shape of a coin. The three arcs AB, BC, and C4 are part of circles with center C. Center C the center, B2 the center, A is the center. So find the perimeter of the coin. So perimeter of the coin, the coin is made up of arc AC plus arc AB plus arc BC. That's the coin. The coin is made of that. Remember the question said the three arcs AB are part of that, just an arc of a circle, which means it's not complete. It's not a complete circle with center C, A, and B respectively. A the center, B the center, C the center. ABC is an equilateral triangle. So we are going to have an equilateral triangle ABC is an equilateral triangle AB with side 2 centimeter. The side is 2 centimeter. Don't forget about the unit. Equilateral triangle, each angle in an equilateral triangle, if you remember, is 60 degree. Each angle is 60 degree. Now, first find the perimeter of the coin. Indirectly, we have to add the summation of the three arcs. That's the meaning. Now, which means that now for arc AB, when you check the arc AB, this is the arc AB. Can you see that? This is arc AB. This is the center of that for arc AB. From here to here, this is the center. And so the formula for arc, length of arc, that's radius for AB, radius of AB multiplied by angle of AB. For AC, radius of AC multiplied by angle of AC. And for BC, radius of BC multiplied by angle BC. So from here, the radius here, radius is center to edge. Now, if A is the center, C is the center, let's say it like this. For A, the crescent said the 3 arc ABC with center ABC. A is the center. If you are going to complete the circle where A is the center, B2 is the center, they are all, this is, so hold on, let me put it like this. So let's say it in this form. Let me put it like this. Now, if A is the center, if A is the center of the circle, let's consider AC as an arc. Let me clean this too. Let me clean this. So it's quite simple. I just want you to see the way I arrive at what I'm about to do. Is an arc. Let me complete the arc. If it's an arc, let me complete the arc, the circle. This is the circle. Can I see it? So if I'm considering A at the center, if C2 is the center, so from C to B is the center of the circle. That will be the radius. From A, this is for arc AC. C is the edge, yeah, while B will be the center. So the radius is 2. If I do the same thing for arc, if I do the same thing for arc, AB, let me complete it. So from B to C will be the center, which means the radius of the circle is 2 centimeters. That's the meaning. The radius is 2 centimeters. That's where I'm going. So let me sketch the diagram again. Like the question said, that we have an equilateral triangle AC, a 3 arc with, we have an equilateral triangle ABC. You know, equilateral triangle, each side is 2 centimeters, like I said, and each angle is 60 degrees. Each angle is 60 degrees. So for arc AB, the radius is 2 centimeters. Radius is in meter, so divide, take 2 centimeters to meter, that's 0.02. So 0.02, that's the radius. The angle is 60 degrees in radian, it's pi/3. The same thing go for each of the arc. They have the same radius and the same angle, 60 degrees. I converted to pi/3 because in circular measure you have to be in radian. At the end of the day, we have 0.02 pi/3. You know, we have 3 arc multiplied by 3. 3 cancel 3. So what do you have? 0.02 pi. That's the perimeter of the coin. 0.02 pi. The next one, find the area of the face ABC of the coin, giving your answer in terms of pi and 3. You have to find the area of the face ABC of the coin. Now to find the area of the face ABC, what they are talking about is inside. The area of the inside. So how did we do that? Okay, it will be easier if I make it of different color. So, but the fact that we are looking for the area of this inside, and at the same time, don't forget we have an equilateral triangle inside. So now, if you check this side like this, ACB. If you check ACB, the one in red color is the sector. Red is a sector. What I shade is a segment. What I shade is a segment. The one in black, the segment. So to find the area of the coin, it would be, let me call the red one A1, which is a sector. The segment A2 is the segment, and also A3 is also a segment. So to find the area of the coin, it will be A1 plus A2 plus A3. It's extremely simple. Now our A1 is a sector. What the area of a sector? Half r squared theta. So don't forget, this is 2 centimeter, this is 60, this is 60, and this is 60. So the area of a sector is half r squared theta. Don't forget our radius, that will be half. Take our radius to meter, 0.02 squared, and theta is pi over 3. At the end of the day, the area of the sector will be 0.02 square pi over 6. That's A1. Let me get my A2. Like I said, A2 is segment. What the area of a segment? Area of a segment is area of the sector minus area of the triangle. That's the formula for area of a segment. And the sector, as you all know, half r squared theta. The triangle, the sector is the sector is half r squared theta, while the triangle in question is an equilateral triangle. What is the formula to calculate the area of an equilateral triangle? The area of an equilateral triangle is s squared root 3 divided by 4. That's the formula for area of an equilateral triangle. You know, where s is the length of the side. So which is 2 centimeter all through. So let's calculate. So from here, the sector, like you know, the radius is 0.02. So A2, remember that A2 is the segment, A3 is the segment, they are the same thing. So that will be 2 multiplied by what I'm about to do. half 0.02 square. The angle is pi over, 60 is 180 over 3, right? That's pi over 3. That will be the angle. Minus the side is 0.02 square root 3 over 4. That's for equilateral triangle. At the end of the day, the area of the segment A2 equal to A3, right? A2 is equal to A3 anyway. So from here, I have 0.02 square pi over 6 minus 0.02 square root 3 over 4. Open the bracket by 2. I have 0.02 square pi over 3 minus 0.02 square root 3 over let's say root 3 over 2, if I'm correct. So let me check it. This pi over 3, this pi over 3, the other one is root 3 over 2. So hence we can now calculate the area of face ABC, which is A1 plus A2 plus A3. Our A1, as shown, 0.2 square pi over 6. My A2, 0.02 square pi over 3. My 8 minus 0.02 square with 3 over 2. Oh, I've already added them together by multiplying by 2. I've added them together. This is A1 plus A2 plus A3. 0.02 square is common, so 0.02 square is common. What left here? Pi over 6 plus pi over 3 minus root 3 over 2. The question said our answer should be in terms of pi and root 3. At the end of the day, we're going to have 0.02 square. Pi over 6 plus pi over 3 will give us pi over 2 minus root 3 over 2. We can still factorize this as 0.02 square over 2 into bracket pi minus 3. You can leave your answer like this, or you can also go further. That gives 2 times 10 to the power minus 4 pi minus 3. That's the area of the face ABC. I believe it's clear enough. Number 5. The first, second, and third terms of a geometric progression are sine theta, cos theta, and is a GP. Yes, T1. This one is T2, and this is T3, respectively. Where theta radian is acute angle. Acute means is less than 90, is not greater than 90, and is not equal to 90. Remember, for the definition of geometric progression, the common ratio of a geometric progression is always T2 over T1, which must be the same thing as T3 over T2. This is a general term of a, which means what I'm trying to say is cos theta over sine theta must be the same thing as 2 minus sine theta over cos theta. So now from here, when you cross multiply, so cos squared theta and you cross multiply, this one will give us 2 sine theta minus sine squared theta. Collect your like term. Cos squared theta plus sine squared theta equal to 2 sine theta. You know, from the general trigonometry rule, cos squared theta plus sine squared theta is 1 equal to sine theta. Yeah, let's make sine theta the subject of formula. We have 1/2, so theta is arc sine 1/2. So to make the work easier, theta arc sine 1/2 is 30 degrees. Since the question said theta is an acute angle, so which means it's correct for theta to be 30 degrees. The next question, using the value of that theta, that's 30 degrees, find the sum of the first term of the progression. What's the formula for sum of GP that the common ratio is greater than 1? A into bracket r raised to the power n minus 1 over r minus 1. That's the formula for sum of GP where the common ratio is greater than 1. We use this when r is greater than 1. If it's less than 1, we reverse it. You can check out this formula in your MF19. So, and your answer must be in this 10. So the sum of 10, n is 1. What's our first term? Our first term for the question, I think, let's go back. First term is sine 30, and sine 30 is half. Is it half? Let's check it. Yeah, it's half. Our first term here is sine 30, which is half. Our common ratio is cos 30 over sine 30. Remember that cos 30 over sine 30 is cot theta. That's 1 over tan theta. Tan theta is 30. What is tan 30? I think tan 30 is 1/3. Yeah, 1/3. And 30 is 1/3. So at the end of the day, the common ratio is √3. So from the given term, the first term is half. The common ratio is √3. Take note of that. First term is half. Common ratio is √3 raised to the power n. That's 10 minus 1 all over our common ratio √3 minus 1. So which will give half. Make use of a calculator. √3 raised to the power 10. √3 raised to the power 10 will give us 243. So 243 minus 1 all over √3 minus 1. So the sum of the first term, 243 minus 1, will give us 242. So all over √3 minus 1. At the end of the day, we have 121 over √3 minus 1. So that is going to be the sum of 10 in the form we expect to get. Number 9, the equation of a curve y equal x squared minus 8x plus 5. Find the coordinate of the minimum point. Now, okay, to find the coordinate of the minimum point, it is advised you take the form to a completing the square form, something like this. You have to make sure the form, if the form is like this, in this case, the minimum point in this case will be minus b and c. The minimum point is also called the stationary point or the vertex. Now, let me get the minimum point from, since y is x squared minus 8x plus 5, to take it to that form, what you need to do is x squared minus 8s. The coefficient of x is minus 4. Minus 8, half of minus 8 is minus 4. You square it and also subtract that minus 4 squared. You add it, also subtract it, plus 5 is still the same. This should be the first topic or second topic in P1. So from here we have x minus 4 all square minus 4 squared is 16. So we have this minus 4 squared is 16. So at the end of the day, y is x minus 4 squared minus 11. So in this case, the minimum point is 4 and minus 11. That's the minimum point. Now the curve is now stretched by factor of 2. When the curve is stretched, it only affects the minimum value of y. The minimum value of x remains constant. So when it's stretched by a factor of 2, the minimum point of x will never change. It's going to be 4. But the minimum point of y, which was minus 11 in the first one, multiplied by 2, that will be minus 22. This is the new minimum point. So the new minimum point is 4 minus 22 after stretching, which can be written as x minus 4 all square minus 22, if you agree with me. So if you expand it, that will be x squared minus 8x plus 16 minus 22. If I'm correct, 16 minus 22 is minus 6. So x squared minus 8x minus 6. This is the new minimum point. Let me call it g of x. This should be a new equation for stretching it. This is a new equation for stretching it. Now, it's then translated by 4 and 1. This plus 4 means that it's moved to the right by 4 units, which can be written as maybe g of x minus 4. It moved to the right by 4 units. This one moved up by 1 unit. So therefore, let's translate the stretch equation. This is what we're looking for, which is the same thing as x minus 4 all squared minus 8x minus 4 minus 6 plus 1. This one will give us x squared minus 8x plus 16 minus 8x plus 32 minus 6 plus 1. At the end of the day, I have x squared minus 16x, 16 plus 32, 16 plus 32 minus 6 plus 1. That gives us 43. So therefore, I can now get the new minimum point of this transform curve using the same method. That will be x squared minus 16x. That will be plus minus x squared minus 8 squared plus 43. That will give x minus 8 all squared minus 64 plus 43. If I'm correct with my calculator, I should be, sometimes the calculator can mess you up. That should give us x minus 8 squared minus 21. So the new minimum point of the transform curve will be 8 and minus 21. That's it. When the graph moves by 4 to the right and 1 upward, this is what we're going to get. Now find the equation of the transform curve. So the equation of the transform curve will be, the minimum point of the transform transform curve is minus say 21, sorry. So the equation of the transform curve, this is, the formula is x minus h squared plus k, where h and k are the vertices. So therefore it will be x minus h squared plus minus 21. This gives us x squared minus 16x plus 64 minus 21. So x squared minus 16x, 64 minus 21, 43. So that, find the equation of the transform curve, give your answer. So in this form, so in this case, a is 1, b is minus 16, c is 43, the integers. That's it. Now the next question, we have to verify the identity. We have to verify the identity. 2x minus 1 bracket 4x squared plus 2x minus 1. You have to verify it. So verification means just do your normal expansion. If they are equal, they're correct. If they are not equal, they're not correct. So let me expand this. 2x times 4x squared is 8x cubed. 2x times minus 1 minus 2x minus 4x squared. 2x times 8x cubed, 2x times 2x. No. 2x times 4x, 8x cubed plus 4x squared minus 2x minus 4x squared minus 2x plus 1. So this is out. What left? 8x cubed minus 4x plus 1. So it's correct, which means this is the same thing as this. Take note. The next one, prove this identity. Okay, proving a trigonometric identity is all about interpreting, simplifying them. That's all. Just simplify, have it in the back of your mind. Tan squared theta can be written as sin squared theta over cos squared theta plus 1. The other one down there, sorry, let me change it to blue. That will be sin squared theta over cos squared theta minus 1. Take the LCM. So we have sin squared theta plus cos squared theta over cos squared theta. That's the LCM of the numerator. So of the denominator, the LCM is sin squared theta minus cos squared theta all over cos squared theta. This cancel this. So sin squared theta plus cos theta, we have 1 over sin squared theta minus cos squared theta. So sin squared theta can also be interpreted as 1 minus cos squared theta. One of the identity. This is minus cos squared theta. It's still there. At the end of the day, we have 1 over 1 minus 2 cos squared theta. That's it. That's what you're asked to prove. So the next one, using the first and second result, we have to solve this equation. Okay, let's see how we're going to apply this. Remember that we've proved that this is the same thing as 1 over 1 minus 2 cos squared theta equal to the new one for cos theta. In maths, when you have a fraction equal to a whole number or fraction equal to fraction, you cross multiply. This is over 1. So what we have 4 cos theta into bracket 1 minus 2 cos squared theta equal to 1. So excuse me. Okay. So open the bracket, that will be 4 cos theta minus 8 cos squared theta equal to 1. So we arrange as minus 8 cos squared theta plus 4 cos theta minus 1 equal to 0. Multiply 2 by minus because of this minus, that will give 8 cos squared theta minus 4 cos theta plus 1 equals 0. Oh, this is q. 4 cos theta times this to give us q. Yeah, so this is q. Let me this is q. This is q. Oh, 8 cos cube theta minus 4 cos theta plus 1. We call that from the first question, number 1 question, we are asked to verify that 2x minus 1 and 4x squared plus 2x minus 1 is the same thing as 8x cubed minus 4x plus 1. If you look at it critically, if 8 cos cube theta minus 4 cos theta plus 1 can be written as 8x cubed minus 4x plus 1 if x is cos theta, right? Yes. So which means that 8 cos cube theta minus 4 cos theta plus 1 will be the same thing as 2x, as 2 cos theta minus 1, 4x squared, 4 cos squared theta plus 2 cos theta minus 1. Yes. So remember that when you break it down, the main equation is equal to 0. So which means that 2 cos theta, which means that 2 cos theta minus 1, 4 cos squared theta plus 2 cos theta minus 1 is equal to 0. So it means 2 cos theta minus 1 equals 0, or 4 cos squared theta plus 2 cos theta minus 1 equal to 0. In this case, cos theta equal to half. It's like quadratic. If you use quadratic formula, we're going to have minus 2 plus or minus b squared minus 4ac. If you use quadratic formula, all over 2a. So we have cos theta to be half, or cos theta will give us minus 1 plus or minus root 5, if you put in a calculator, all over 4. So in this case, cos theta equal to half, or cos theta equal to minus 1 plus root 5 over 4. One will give us 0.3090 the other gives minus 0.8090. So theta arc cos half. Arc cos half will be 60 degree. Second function, 60 degree. Oh, sorry. This 60 degree. Arc cos 0.3090. That give us this one will give us arc cos of 0.3090. This one, remember that this one is negative. I'm coming 0.8090. I didn't put the negative. You see it, what I'm saying now. Theta is 60 degree, and theta arc cos of this will give us 72 degree. I know it's positive. CAST. This is 70. Where is cos positive? Cos positive in the last quadrant. Cos is positive in the last quadrant, which is 360 minus theta. If you do 360 minus theta, it will go beyond the range 180. So no need of applying that. Let's see this one. Arc cos of second function cos 0.8090. That gives us this is 72 degree. And let me be sure of this. Let me be sure of the one that is positive. Minus 1 plus root 5 divided by 4. Okay, that's positive. So minus 1 minus root 5 divided by 4. Okay, correct. So this is positive. CAST. Where is cos positive? Yeah, 360 minus theta. We can't use that. 72 we meant 72. Arc cos of this second function cos of 0.8090. That gives 36 degree. That gives 36 degree. This one gives 36 degree, but it's negative. Where is cos negative? Cos is negative in the second quadrant and in the third quadrant. And the formula in second quadrant is 180 minus theta. 180 minus 36. 180 minus 36. We have 144. And it's also negative here. But if you use this third quadrant, the value obtained will be more than the range. So therefore, the value of the theta requested in this question should be 36 the principal, 60 the principal, 72 and 144. That's it. But let me see it. That's 144. Yes. 72 and cos of that. 60. Yeah. Yeah, exactly. You can do 60, 72, 144. Number 8. Question 8. Function f and g are defined by f of x equal x plus a squared minus a squared. We find, okay, for this function, for f of x, let me see the graph. The minimum point is minus a, negative minus a, and for y2 is minus a. So which means most likely this is a turning point. It's going to turn here. I think it's going to cut here if I expand it. So this is the vertex. Okay, so the range, like the question said, the domain is x less than or equal to minus a, so it's still going. So it never, I think it's, if to sketch it properly, the graph will turn here. I don't think it will go beyond this. I don't think it will go beyond this point, because for f of x, the domain is x less than or equal to, it starts from minus a. The domain is y. From here, from what I can see here, the range, I got the range from the vertex of f of x minus a and minus a. So the range should be f of x greater than or equal to minus a. Or, okay, I'm still coming back to it anyway. I'm coming back to it. Don't worry. Find the expression for inverse of f. Since f of x is x plus a all square minus a, so let's find the inverse. So f of x equal x squared, when you expand, 2ax. No need to find the inverse. The inverse is just to make x the subject of formula. So let's make x the subject of formula. To find the inverse, the first step is to make x the subject of formula. So let's do that first. So you put f of x is y, x plus a all square minus a, which give x plus a all square equal to y plus a. So x plus a plus or minus square root of y plus a. So from here, x will be minus a plus or minus square root of y plus a. So the inverse, minus a plus or minus square root of x plus a. Now, is it plus or minus? I'm going to choose plus. Is it a plus or minus? So what I'm choosing plus is, when you check the range of this, remember that the range of inverse, the domain of function, the domain of this f of x will be the range of the inverse. So the range of this inverse will be the domain of that function, and domain of that function is x less than or equal to minus a, which will be the range. So since the range is this is the range, why the domain of this function, the domain of this function is the range of the normal function, and range of the normal function is this. So the domain is increasing. That's why I choose positive, because the domain of this function is x greater than or equal to what? Minus a. That's why I choose positive. It's correct. Now state the domain of the function. Okay, like I said earlier, let me change my color so it should be clearer. For the function, the vertex of that function is minus a and minus a. Vertex means the minimum point is minus a and minus a. Now when you check which vertex is also the minimum point of x and the minimum point of y. And from the question, they said the domain is x less than, or from this, look at it, x less than or equal to minus a. The domain of this function will be the range of inverse. So the range of inverse is less than or equal to minus a, like I said earlier. Now, what is the range of this function? We know the domain. What is the range? To get the range, just look for the value of y. At the stationary point. The value of y at the stationary point is minus a. If you check the graph is going up, which means the minimum value is minus a, which means it's still going up, it's increasing. So the range of this function is f of x greater than or equal to minus a. That will be the domain of the inverse. X is greater than or equal to minus a. That's it. Now, C question. Now, given that a equal to 7 over 2, now we are given the value of a to be 7 over 2. We have to solve gf of x. What is the meaning of gf of x? Which means you have to place function of x inside g of x. Function of x inside g of x. Where is our g of x? Oh, it's in the second question, 2x minus 1. Since our g of x is 2x minus 1, I remember that our f of x, I think, is x plus a all squared minus a. So let's find gf of x. That's f of x inside g of x. So that will be 2 bracket x plus a all squared minus a minus 1 equal to 0. Remember the question gave us a to be 7 over 2. 7 over 2 all squared minus 7 over 2 minus 1. So from here equal to 0. From here, open the bracket by 2, we have 2 bracket x plus 7 over 2 squared minus 2 times 7 over 2 minus 1 equal to 0. So we have 2 into bracket x plus 7 over 2 all squared minus 7 minus 1 equal to 0. So this gives x plus 7 over 2 all squared equal to 8. Solve means find the value of x. From here, divide both sides by 2. We have x plus 7 over 2 all squared equal to 4. So we have x plus 7 over 2. It gives us plus or minus square root of 4. So x plus 7 over 2 is 4. Square root of 4 is 2, or x plus 7 over 2 is minus 2. So we have 2 minus 7 over 2, or minus 2 minus 7 over 2. So the value of x, 4 minus 7, is minus 3 over 2, or the value of x is minus 4 minus 7 minus 11 over 2. That's the value of x. That's the question. The next question, number 9, integration. Now, okay, actually this region is shaded. The question asks us to, the first question, the diagram shows curve with equation. We check the curves. This line, let me call it M, and this line N. Remember that M is above N. That's the first thing I will call your attention to. I'm coming to that. N is above N, and they are all above positive x value. Okay, I'll back to that. The first question, the diagram shows the equation y equal 2x half plus 13x minus half and y equal 3x minus half plus 12. So the curve intersect at point A and B. So find the coordinate of A and B. Now since they intersect, what you expect to do is to equate the two equations. 2x raised to the power half plus 13x minus half. 2x raised to the power half plus 13x raised to the power minus half equal 3x minus half plus 12. Because I equated them because the question said they intersected. Now let's collect the like term. So 2x raised to the power half minus 12. Collecting the like term means I'm rearranging it to bring together the look-alike. In this case, the look-alike is the one with x raised to the power minus half. At the end of the day, I have this. So 3 minus 13, I have minus 10x raised to the power minus half. So let's rearrange. Or what do you think I should do? Okay, now to make the work easier. Oh, something just come across my mind now. Let me check this space. Okay, into mind to make the work easier. This is 2x raised to the power half minus 12 minus 12 is equal to minus 10 over x raised to the power half. Put x raised to the power half as p. Then I have 2p minus 12 equal minus 10 over p. Yeah, so cross multiply, then I have 2p squared minus 12p plus 10 equal to 0. Divide through by 2, p squared minus 6p plus 5 equal to 0. Quadratic equation, p squared, please help me out. Should it be plus 5p minus 5p minus p plus 5 equal to 0. So p into bracket p minus 5 minus 1 to bracket p minus 5 equals 0. So we have p minus 1, p minus 5 equal to 0. Sorry, p is 1 or p is 5. Recall that my p is x raised to the power half. Remember, I put p as x raised to the power half. So if x raised to the power half equal to 1, it means x is 1 squared. This one means x is 5 squared. So the answer is x is 1 or x is 25. That's it. So the point of intersection, they intersected when x is 1. Most likely x will be 1 here and x will be 25 here. That's it. So to lead us to the next question, find the area of the shaded region. The shaded region is bounded by 25 and 1, and we have two curves. So this is what we do if you have two curves in this situation. The area of the shaded region will be, they are bounded by the area of shaded region anyway. The formula is y dx x2 x1. So it will be integral 25 and 1. So since n is greater than n, is above n, to be n minus n dx. That's the whole idea. So at the end of the day, the area of the shaded region 25 1 n. Our m is 3x minus half plus 12 minus our n is 2x half plus 13x minus half. So at the end of the day, let me change it to blue. It's too dark. So the area, don't forget your integral, 25 1. So 3x minus half plus 12 minus 2x half minus 13x minus half dx. At the end of the day, our area, I'm here to integrate, that's why I'm still putting this. So 3 minus 13, of course, minus 10x minus half plus 12 and minus 2x raised to the power half. Now I've simplified them, then I can now integrate. So the area will be, now I'm integrating, I've taken away the integral sign, minus 10x minus half plus 1. I think it's half over half, formula for integration. Remember, to integrate x raised to the power n dx, it will be x raised to the power n plus 1 over n plus 1. So this is definite integral, we don't need the arbitrary constant anyway. When you integrate a constant, it's 12x, while this one will give 2x, half plus 1, 3 over 2 over 3 over 2. Don't forget, the limits are still very valid. So when you simplify this one, you're going to give us minus 20 x raised to the power half plus 12x. This one will give minus 4 over 3 x raised to the power 3 over 2. Now make use of your limit. When subtract, so you're going to do when it's 25. When x is 25, that's minus 20, 25 raised to the power half plus 12 times 25 minus 4 over 3, 25 raised to the power 3 over 2. Subtract it from when it's 1, minus 21 raised to the power half, 12 times 1, minus 4 over 3, 1 raised to the power 3 over 2. So the area, minus 20 times 25 raised to the power half, that gives minus 100. 12 times 25, and 12 times 25, I think it's 300. The other give minus 166.7. Why the one inside this bracket, minus 20 times half plus 12 times 1, this will give us minus 9.33. So when you do this mathematics, you're going to have 33.3 minus times minus plus 9.33. It gives us 42.63 square unit. That's the area of the shaded region. Question 10. Oh man. 10th question. This is also a differentiation question. How do you go about it? Please. Welcome back. So the equation of the curve y equal f of x, where f of x is this, that power is, this is 5 over 3, I think it's 2 that 5 or 3. Find the x coordinates of the stationary point and determine the nature coordinate, x coordinate. Okay. Now, at stationary point is something you're familiar with. The y dx, which is the same thing as x, complement of x, is always equal to 0 at stationary point. So, which means we need the y dx. So the function of x from the question, let me write it clearly, is 4x minus 3 raised to the power 5 over 3 minus 20 over x. 20 over 3, sorry. So let me differentiate this. To differentiate it, you know what to do. The power comes to the back of the function in the bracket. Subtract the power from 1 from the power and multiply it by differentiation of what is inside the bracket. This is how to differentiate function of function, or the function with a power. This is how to do that. At the end of the day, so the y dx will be 5 over 3, 4x minus 3, 5 over 3 minus 1, I think 2 over 3. Differentiation of what is inside the bracket is 4 at the end of it. So minus, oh, no, when you differentiate 20 over 3, I think it's 0. No, it's 20 over 3x. Okay, sorry. So, you know, this is x. So when you differentiate 20 over 3x, we have 20 over 3. So minus 20 over 3. So I remember that at stationary point, the y dx is 0. So our dy dx is 5 times 4, 20 over 3. 4x minus 3 raised to the power 2 over 3 minus 20 over 3 equal to 0. At the end of the day, I have 20 over 3, 4x minus 3 raised to the power 2 over 3 equal to 20 over 3. This cancels this. So I have 4x minus 3 raised to the power 2 over 3 equal to 1. So, you know, you have to be very careful. 4x minus 3 raised to the power 2 over 3, it means 4x raised to the power 1 over 3 raised to the power 2. That's the meaning. At the end of the day, we are left with 4x minus 3 raised to the power 1 over 3. When square go to the other side and become square root of 1, plus or minus. So from there, we have 4x. Oh jeez, thank God. From there we have 4x minus 3 raised to the power 1 over 3 plus or minus 1, that's 1 or minus 1, which is the same thing as 4x minus 3, 1 cube or minus 1 cube. So it gives us 4x minus 3 equal to 1 or 4x minus 3 equal to minus 1. At the end of the day, x here will give us 1, y x here minus 1 plus 3, that's 2. X here will give us half. These are the two values of x coordinate of stationary point. The question asks us to now determine the nature of this coordinate. The nature means are they minimum or maximum point. To do that, I need to do second derivative. So the second derivative is continuation of the first derivative. So you know the first derivative is 20 over 3 4x minus 3 raised to the power 2 over 3 minus 20 over 3. So the second derivative will be 2 over 3, like we did the first one. The power shift to the back of the function, subtract 1 from the power, that gives us minus 1 over 3 minus, when you differentiate 1 over 3 we have 0. So the second derivative, 40 over 9 bracket 4x minus 3 raised to the power minus 1 over 3. That's the second derivative. Now put those functions there. When x in the second derivative, let's put when x is 1. So when x is 1, that's 40 over 9. 4 times 1 minus 3 raised to the power minus 1 over 3. It gives when x is 1, 4 minus 1, it gives minus 40 over 9, which is less than 0, which means when x is 1, since it's less than 0, that's the maximum point. Let me check it again. When x is 1, so 4 minus 3 is 1. 4 minus 3 is 1. So 40 over 9. No. It gives 40 over 9, not minus 40 over 9, which is greater than 0. So since it's greater than 0, which means when x is 1 is the minimum point, because the y dx is less than 0. Because the y dx is greater than 0. Now when x is half, substitute for this, so it's a power minus 1 over 3. This one will give us 2. This one will give us minus 40 over 9, which is less than 0. So which means when x is equal to half is the maximum point, because the y dx is less than 0. That's 0. There's still space, and I was managing space. So I believe you understand this. So x is equal to 1, the minimum point. X is equal to half is the maximum point. The last one states a set of values for which the function is increasing. For increasing function, the y dx is greater than or equal to 0. From the previous question, this is the y dx. Should be greater than or equal to 0. At the end of the day, so we are going to have something like this. So at the end of the day, remember that when we simplify this, we arrive at something like, it can be 1 or minus 1. So this one is 1 or minus 1. 1x will give us, I think 1x give us, let me do it like this. Sorry, I'm a bit tired. 4x minus 3. 1 is 1. 4x equal to 4. That one give us 1. The other, 4x minus 3, if it's minus 1, 4x minus 1 plus 3, that's 2. The other x give us half. We have two values of x, 1 and half. I think that is it 1 and half? Oh yeah, let me check it. 1 and half, just to be sure. Yes, 1 and half. minus, okay, the same thing there. Okay, you have to value of x 1.5. So at the end of the day, the answer will take this form: x will be less than or equal to half, x will be greater than or equal to 1. That's it. So the value of x for function to be increasing function. Number 10, the last one. Number 10, the last one. Let me take water, a few minutes. Okay, is it number 11? Oh, we're done. The last one. The coordinate A, B, C are two. A has its own coordinate, as you can see. B has its coordinate, and C has its coordinate also. Where P is constant, the line AB is perpendicular to BC. Find the value of P. AB, according to this condition, is perpendicular to BC. It means the gradient of AB multiplied by the gradient of BC will give us -1. That's a minute. So A 6, 4, x1, y1, B P7, x2, y2. Let's find the gradient. No, gradient is change in y over change in x. So the gradient is change in y, y2 minus y1. That's 7 minus 4. 7 minus 4. Change in x, p minus 6. That's gradient for AB. Gradient for BC. Okay, where's B? A, B, B, C. 18 minus 7. 18 minus 7. Change in y of BC. This is B, this is C. And change in x, 14 minus P. 18 minus 7, that's 11 over 14 minus P. So since they are perpendicular, the product of the two gradients is -1. So for AB, which is 3 over P minus 6, multiplied by 11 over 14 minus P, will give us -1. So at the end of the day, we have 33 over P times 4, 14P minus P squared, 14 times 6. I'm multiplying the denominator. 14 times 6 will give us -84. P 14, P squared minus 84 plus 6P equal to -1. So okay, let me just do it like this. So we have 33 over okay, we have minus P squared 14p plus 6p, that's 20p, minus 84 minus p squared, 14p plus 6, 20p minus 84 equal to minus 1. Then cross multiply, that will be minus 1 minus p squared plus 20p minus 84 equal to 33. Open the bracket, so we have p squared minus 20p plus 84, so equal to 33. So we have p squared minus 20p plus 84 minus 33 equal to 0. So 84 minus double 3, 51. So I have p squared minus 20p plus 51 equal to 0. So let me reconfirm before I go into the quadratic formula. AB x1 y1 x2 y2, gradient y2 minus y1, this is y2 y1 3, x2 x1 p minus 6, correct? For BC, and this is BC, y2 y1, 18 minus 7, 40 minus p. Okay, it's correct. So let's use the quadratic formula. 2 factors minus b plus or minus b squared minus 4ac. A is 1, c is 51 over 2a. So 4 times 51, 204. So 400 minus 204, 196. So 20 plus or minus square root of 196, 14 divided by 2. So p, we give 20 minus 14, 6 over 2, or 34 over 2. So at the end of the day, 6 over 2 is, at the end of the day we have 6 over 2 is 3, 34 over 2 is 17, but we are given the condition that p is less than 10, so we go for the one that is less than 10. P is equal to 3, that's the answer. That's it. The last was not the last question on this paper. What the last said, a circle passes through the points A, B, and C. Okay, let me rewrite point A 6, 4. Point B is P and 7. That's P is now 3. While point C is 14, 18. The circle passes through the point A, B, and C. Find the equation of circle. But let me just, I'm going to tweet this in my topical that's coming up. Let me use the opportunity to apologize. I've been inactive for some time. My laptop crashed. I had to get a temporary one for now. Now this is like equation of, normally the formula for equation of circle you are familiar with. That's what I'm still going to use. X minus h all squared plus y minus k all squared equal to radius squared. This is what I'm still going to use, which means I need to get the center. Now these are the steps. So we have 3 points. These are the steps. Take note of this point. Now, for AB, I'll divide into 2, AB and AC. For each one of them, you need to get For each one of get, you get the midpoint. You get the midpoint. For each one of them, you get the gradient and equation of perpendicular bisector. This is how you're going to do it. So for each of the point, for AB and AC, you need to get this. Now let's get the midpoint for AB. The midpoint for AB. The midpoint for AB, you know the formula for midpoint: average of x and average of y. Average of x, 3 plus 4. This is average of x is 3 plus 6, 9. 9 over 2, that's the average. Y, 7 plus 4, 11 over 2. That's the midpoint of AB. Now get the slope of AB2. Change in y over change in x. There's no space, that's how I'm doing this. Change in y. 7 minus 4, 3. 3 minus 6 minus 3. The gradient is minus 1. I'm looking for equation of perpendicular bisector. Then you flip the gradient, perpendicular bisector. The gradient is now 1. I don't have time to explain with the diagram, but in my topic I will see the analysis. This is gradient, so let me get the equation of perpendicular bisector. Which it has to pass to the midpoint. Y minus y1 equal to the gradient of perpendicular bisector is 1. X minus x1. No. Y is 11 over 2. X is 9 over 2. So equation of perpendicular bisector, this is it. Equation 1. Do the same thing for AC. Get the midpoint of AC. For AC, that's AC. 14 plus 3. AC, so 14 plus 6, 20. 20 over 2, 10. Midpoint. 18 plus 4, 22 over 2, 11. This is the midpoint for AC. Midpoint. MP. This is the midpoint for AC. Then the next one, slope for AC. I'm doing this for the space. Slope for AC. Slope for AC is going to give us right 2 minus right 1. 18 minus 4, 14. 14 minus 6. But 18 minus, what was it? 18 minus 4, 14, and 14 minus 6 is what? 8. Okay. So the gradient for this one is 7 over 4. Remember, perpendicular bisector equation, you have to slip this and you flip it. Minus 4 over 7. We can now get the equation of perpendicular bisector. Y minus y1 minus 4 over 7, x minus x1. Equation 2. So solve equation 1 or 2 together. 1 can be written as, let me see if I can manage the space of the other space. 1 can be written as y equal x minus 9 over 2 plus 11 over 2. So 1 can be written as x plus 1. Turn to equation 3. Now equation 2 can also be written as y equal minus 4 over 7x plus Am I correct? This is 7 over 4 minus 4 over 7. Plus minus 4 over 7x plus 40 over 7. I think so. Yep. So plus 11. So this equation can be written as minus 4 over 7x 40 plus 77 117 plus 117 over 7 down to equation 4. So now equate equation 3 and 4 together. So x plus 1 equal to minus 4 over 7x plus 117 over 7. So at the end of the day, so I have this goes there, 7 plus 4, 7 plus 4, 11, 11x over 7, 117 minus 117 over 7 minus 1, 7 minus 1, that's 117 minus 7, 117 minus 7, I have 110, 110 over 7, this cancel this, 110 divided by 11, so my x is 10. If my x is 10, you know one of the equation is y equal to x plus 1, this y will be 11. So the center of the circle, this is how you get the center of the circle, is 10 and 11. Now to get the radius, so the radius is distance between the center and any point, anyone, you get the same answer. So the radius is, the center is 10 and 11. Let me pick point A. Point A is 6 and 4. So the distance, so get the radius. You get the radius, that will be x square root of x2 minus x1, x1, y1, x6 minus 10 minus 4 square 16, 4 minus 11, 7 minus 7 square 49, and be sure x, so 49 plus 16, 65. So the radius is square root of 65. If we check it with any point, it could be B, it could be point C, you get the same radius, center and any point. Hence, the equation of this circle, using the formula, this formula will be x minus 10 square plus y minus 11 square equal to the radius. Radius is square root of 65 all square. At the end of the day, the equation of the circle will give us this, equal to 65. That's the equation of circle. I believe it's clear. Please subscribe to get details and more explanation on the new techniques. Now, the last question, we have to find the equation of tangent to the circle at C. Okay, let's draw the circle. We have the center center to any edge. Center is 10 and 11. There you get. Now it said at C. Let me call the center C complement. Point C from the question is 14, 8. Now you are looking for equation of tangent. What's a tangent? A straight line that touches just one point in a circle. That's a tangent. So this is what the question. This is the tangent line. This is it. Now from this question, you see that CC. Let's find the slope between. Let's find the gradient. To find the equation, let's find the gradient of CC. The gradient using the formula y2 minus y1. Y2 minus y1. 8 minus 11 is this is 14. This 14 and 18. Point C is 14 and 18. 18 minus 11, 4. 14 minus 10. Yes, 18 minus 11 is 7. We have 7. And 14 minus 10 is 4. That's the gradient. Remember that this gradient CC is perpendicular to the tangent, and we are looking for equation of the tangent. So 7/4 times gradient of tangent should be equal to -1. So the gradient of our tangent should be this is 18. 7/4 should be -4/7. That's gradient of tangent. X1, Y1, let me be sure. X2, Y2. 18 minus 11, 7. 14 minus 10, 4. When you strip it, flip it, -4/7. So hence the equation of tangent should be y equal to, let me use this, mx plus c. At point C, what is y? Y is 18. The gradient is -4/7. At that point, x is 14 plus c. 7 here 1, 7 here 2. We have 18 equal to -4 times 2 minus 8 plus c. So c will give us 26. So the equation will be y equal -4/7x plus c, which is 26. So at the end of the day, the equation of tangent in form of this, that have 7y equal to -4x plus 26 times 7. That's 182. So at the end of the day, we have the form required: 7y plus 4x minus 182 equal to 0. That's the equation of tangent. See you in the next video. Thank you.